Hi, welcome to this summit talk on building robots to make hospitals smarter and safer. I'm Pulkit Kapoor and I do business development at AWS for robotics and autonomous systems. My background is in robotics, and I've spent the last 10 years helping enterprises in their robotics and digital transformation journey. I'm excited to talk to you today. So let's dive in. In today's talk, we'll start with an overview of robotics in healthcare and the role AWS plays in this space. Next, we'll look at some of the challenges to building intelligent healthcare robots and ways we can accelerate robotics development and make it easier for developers. Then, we'll look at some examples and customer testimonials of healthcare robots in hospital settings. I will also give you a demo of how to build and simulate your robot in a virtual hospital environment. Lastly, we'll look at AWS RoboMaker and briefly discuss the value that it has enabled robotics companies to be successful. The role of robotics in healthcare is critical to reduce the risk of exposing patients and staff to harmful bacteria and viruses. AWS has had a front row seat to the impact of robotics in healthcare by accelerating the work done by startups and enterprises. AWS has a commitment to create enterprise-grade solutions for healthcare customers that can help transform your operations at each point in the healthcare value chain. From cloud-connected robots that enable IT cloud transformation to analytics and digital payment solutions for a safe and automated healthcare experience. We look forward to being a trusted partner to help accelerate transformations and unlock insights that enable data-driven, digitally enhanced healthcare. Customer obsession remains at the focus of how we work with organizations across the spectrum of care. From healthcare providers that are focused at the point of care, to government ministries that create health policies for populations, to payers that finance or reimburse the cost of care, to healthcare IT, NGOs, and medical device vendors that provide application-specific solutions throughout the healthcare industry. AWS provides the foundational technology to drive security, compliance, agility, and innovation. Our focus on technology solutions means that the entire healthcare industry does not have to worry about the undifferentiated value of commodity IT, and they can focus on what matters most, the patients. The customer obsession is even more true in healthcare robotics, where robots not only need to be safe, but also need to earn the customer's trust. Automation has been around healthcare for many years. Medical devices that perform routine patient tasks like diagnostics and patient management have been widely adopted in the last 20 years. The last 10 years has seen a growth in social robots, robots for transportation and telemedicine. There's still a number of highly repetitive and manual tasks like test tube handling and pipetting as part of sample collection and testing that can be automated using autonomous robots. All trends point to strong growth in autonomous mobile robots in healthcare in the next few years. In the next 5 years, medical robot expenditure is expected to increase by 20% to $25 billion, and we estimate the number of non-surgical robots to increase to fourfold to 60,000 units by 2025. And this growth is not just limited to robots for patient care. By 2030, we expect 70% of all mobile material handling to be autonomous. Here are the 3 reasons we have heard from customers for using autonomous robots in healthcare. First, robots are used for patient management and telemedicine in hospitals. Robots are used for concierge and for remote supervision when healthcare practitioner cannot be there to provide critical care on time. Some hospitals are also piloting robotic wheelchairs and walkers, such as the one shown in this picture, to provide personalized care. Second, robots are used to disinfect and sanitize surfaces and high-touch spaces. Robots use UV light to decontaminate patient rooms and hallways. This has become increasingly important as hospitals try to create a safe environment for patients and staff. Third, robots are used for transportation or contactless delivery of essential items such as medical equipment, medicines, and food. According to IFR, a typical 200-bed hospital, robots can reduce the amount of mileage that nurses spend each day, giving nurses more time for critical patient care. And the impact robots are having in healthcare is critical because robots not only help put patients' health needs first, but also remove the tedious routine task away from health practitioners and doing them more efficiently and safely. But robotics adoption in healthcare is still limited and nascent. This is because building robots with a high degree of intelligence and autonomy is both difficult and time-consuming. Firstly, building an autonomous robot requires specialized robotic skills in key areas such as computer vision, navigation and path planning, as well as AI. There's an opportunity to make this simpler by providing AI services that robotics applications can call upon. Secondly, roboticists spend a lot of time iterative development and prototyping as they evaluate the different components needed for autonomous behavior and evaluate them for both functionality and cost. Cloud-based simulations can help here and increase the speed of prototyping in the simulated environment. Additionally, not all developers have access to a robot or have access to real-world hospitals to test their solutions. A simulated environment is a huge help in such cases. The three core benefits that we have heard from customers for using simulation in robotics development are: first, the ability to reproduce and test the exact scenario that has caused unexpected behavior in the past. This includes edge cases and unsafe conditions. This is difficult when testing with physical robots. Second is the ability to expand test coverage by programmatically testing hundreds of scenarios in parallel and using repeatable simulation instances. Third, you can speed up the clock and run simulations at faster than real time and get results in a fraction of time it would take in the physical world. And this matters for your business because it means faster time to market for your next robotics project, increased feature release velocity for your teams, and less time spent debugging expensive defects found in the field, especially for safety critical applications in healthcare. So what are the common uses of simulation in robotics? First, robotics developers are using simulation to test more robustly for a variety of scenarios and edge cases, such as this PR2 robot in a hospital ward. We'll talk about this more in depth later. Simulations are being used for prototyping and covering a multitude of variations in the real world, such as these hospital furniture models. Lastly, you can use simulations to train machine learning algorithms more rapidly by testing a variety of different scenarios, such as different hospital layouts, as shown here. The AWS RoboMaker service is accelerating the development of hospital robots. We have developed an open source, high-fidelity hospital simulation environment. This open source environment helps healthcare robotics companies get started with testing and simulation easily and quickly. The developers can test their robotics application in realistic hospital environment and simulations. These simulations can be launched with different environment conditions, and you can run hundreds of them in parallel using RoboMaker's Batch API. The simulated test cases have realistic physics for all the hospital assets that help test the robot behavior in safety critical situations such as around patients and in crowded hospital hallways. These tests can be integrated into a continuous integration and a continuous deployment pipeline for automated regression testing, thus allowing customers to increase their development velocity and improve code quality without additional development resources. Here's a sample 3D simulation of a hospital world in Gazebo Simulator with the rendered PR2 robot. The robot, as you can see, is in the hospital lobby with patients and staff in the background. Let's take a closer look at this simulation. The hospital world is created as an SDF, or a simulation description format, which is an XML format that describes objects and environment in the simulation. Within the world are 3D objects such as people and lobby furniture. These are also SDF, and they are meshes overlaid with visual appearance. Finally, the robot itself is also a special type of SDF called the URDF, or the Universal Robot Descriptor, which defines not just how the robot looks, but also how it behaves. To illustrate customer challenges in healthcare robotics, I'm going to walk you through 3 customer examples and show how RoboMaker has been helpful in solving them. So let's take a look. Milvus Robotics is a 10-year-old autonomous mobile robotics company based in Turkey. Last year, Milvus started developing the SAGE-2 robot to help prevent the spread of infectious diseases. Milvus needed to quickly prototype and the development and testing efforts to get to market quickly and meet this demand for autonomous disinfecting robots. Milvus wanted to test their robot will be able to perform safely in hospital settings, but did not have access to a hospital environment for testing. Milvus used AWS RoboMaker to jumpstart their robotics testing. Engineers at Milvus used the AWS open source hospital environment and ran software tests in RoboMaker for safely navigating the virtual hospital environment. Engineers can run these tests automatically in a continuous integration pipeline with every code check-in and before every software release. This quote from Milvus co-founder and CIO Gökhan Ertunç describes how Milvus was able to save time and money and accelerate their testing efforts. Milvus Robotics found RoboMaker essential to their healthcare robotics development. They say that with RoboMaker, we can forget about infrastructure and focus on development and testing. We implemented a RoboMaker simulation CI pipeline and can easily test robots in many different environments and scenarios, resulting in a huge quality improvement. Now that's inspiring. Next, JetBrain Robotics is a company based in India, building advanced transportation and patient care solutions for hospitals using autonomous mobile robots. JetBrain was recently acquired by Solaris, a Canadian company pioneering automated disinfecting solutions for hospitals using UV. Like any startup, JetBrain is resource constrained. The first challenge they faced was that they didn't have the resources to provide each developer with a robot. Often at the start of the project, there is only one robot for the developers to test on. But the bigger challenge was that JetBrain did not have access to a hospital or have the resources to recreate the hospital environment in their local testing lab. In order to solve this problem, JetBrain turned to simulations on their on-premise system. However, this proved to be expensive and was very time-consuming to set up. So JetBrain used RoboMaker and its managed simulation environment to help scale their simulation efforts. They use the AWS open source hospital environment with its high fidelity model assets to test their robots' obstacle avoidance and navigation functionality, as you see in this video. Here's a quote from JetBrain founder and CTO Ajay Vishnu on the benefits of using RoboMaker for testing their disinfecting hospital robots. Since adopting RoboMaker, we have been able to reduce the amount of resources we spend to onboard new developers to our team, and we have been able to improve test quality and coverage for our robots. Now that's impactful. Lastly, I would like to talk about telepresence robots from Rumi Robotics in Mexico. Rumi builds custom robotic solutions and want to prototype ideas quickly. RoboMaker simulation enabled them to quickly test their proof of concepts and develop hardware and software in parallel. Alfred Pulido, CTO of Rumi, felt that using RoboMaker gave them an extra 5.5 weeks of efficiency. Teams can run simulations all day and prototype ideas uninterrupted without waiting or sharing hardware prototypes. So we've heard from these customer examples, but I want to show you live how you can set up and simulate your robot in a virtual hospital environment using RoboMaker. In today's demo, we will use the AWS Cloud9 development environment. You will see that I have cloned out a ROS simulation environment. In this ROS application, we have the robot workspace as well as a simulation workspace. You'll notice that the simulation workspace is what we are going to focus on because that's the one that, because we're simulating a robot. So in order to start, we're gonna set up a ROS workspace and do the Qualcomm build and bundle steps. Next, we're going to copy the bundle and upload it to S3. We will reference these when we need to create a simulation job. So here's the bundle uploading on S3. Now let's create the simulation job. So here we're just going to input the simulation job details, starting with the number of hours that we need to run the simulation for, what the failure behavior is going to be, as well as what the ROS distribution will use. So we're going to use ROS melodic. We can also set up INM to apply and grant permissions to our simulation instance. Here I'm going to use my INM permission that I've set up previously. You can also set up a threshold for compute resources in simulation units, which is what the service uses for billing. Here I'll set up the output directory for my logs, and you can optionally also set up networking as well as some tags. We're going to skip them today. So let's hit next. Here you can specify a robot application. The robot application is the code that actually runs on the real robot. Since we're not actually going to use a real robot and use a simulated robot, we're going to not provide this today. So here we're going to provide the simulation application that we uploaded to the bundle as a bundle on S3. So that simulation application requires the package name, the launch file name, which is the hospital.launch file, as well as you can provide tags to track the application and get data into it. For example, you can specify at what location do you want the robot to start. So since I want the robot to start in the middle of the lobby, I'm going to say 00 there. You can also set other applications like application connectivity and streaming. We're going to skip that today. So next, we just review all the different settings, and in order to create the simulation job, here you'll see that I provide the link to the S3 bucket that has my simulation application that I had built and bundled and upload it to S3. So everything looks good. So let's hit create. So now RoboMaker is setting the underlying instance where it's setting up your ROS distribution and setting up Gazebo for you. So this will take a couple of minutes and for it to set up and give you access to the Gazebo, the terminal, and the different applications. So let's do that. Okay, so I skipped ahead here and it's running. So now I'm going to start the GZ client application, which is the Gazebo simulator. So let's click on that. So this is the Gazebo simulator application, and you can see the hospital environment. You can use your mouse to change the view, and there in the center of the lobby, you can see the robot. So this application, you can find it on GitHub on the link below. And it's open source and you can download it and use it. So here, we can pan and tilt, and you can see that this is a pretty big environment with a number of rooms, triage stations, a lobby. We also have ramp and elevators. So it's really realistic and matches what a hospital would look like. Next, I want to also be able to visualize my sensor data, so we're going to use RViz. So let's set that up. So in RViz, we can add ROS topics to view the sensor data from the different sensors that are available. So we'll start with the robot model. So you can see that it adds the PR2 robot model in the center of the grid here. Next, we're going to add the map. The robot creates a map of its environment using a process algorithm known as SLAM, or simultaneous localization and mapping. The topic here is the /map topic, so we're going to add that. And in a second, you'll see the map here. So the white or the gray region is what the robot has currently mapped, and the rest of it is what is not mapped. Next, we'll also add the pose topic. The pose is what the goal location that you need to, if you need to give the robot is. So here we're gonna set the goal as the pose as the simple goal. So that's great. Now the last thing I want to do is visualize the path of the robot when the robot moves to the goal location. This path is generated by the path planner. So we're gonna use the simple base pose here. So great. So now that we have all the topics visualized, what I can do is in RViz, I can set a 2D nav goal. Here you can see that part of this environment, what the robot can see with its sensors right now, with the laser sensors, is mapped, and some of it is not. So I'm going to give it a goal towards the lower half of this to go into the room where it's not currently mapped, and we'll see how the map updates. So let me bring up Gazebo so we can look at how the robot actually is moving in the real environment. Okay, so let's keep that side by side so you can see. So we can see the robot moving in RViz, and if I zoom in, I can see the robot moving also in Gazebo. And so the robot, the green here is the obstacles-free path that the robot has created. So you can see that that lower half of the screen where that room was not mapped, and we can see the map being updated. So one of the things we want to see is the robot creates this map using its LiDAR sensor. So let's visualize the laser scan topic. And it does that with these little red dots for visualization. So I'm going to increase the size so we can see the laser scans here. So when we do that here, so now you can see the red scan of the laser. So this is how it knows how to avoid obstacles, or what is an obstacle-free path. So it's reached the point, but we also set an arrow indicating what is the direction that the robot needs to face. So here you'll see that the robot has reached its destination, but the pose is incorrect. So it's going to turn and align itself to that vector. So the pose, so it's facing in the right direction. So there we can see that it's doing that. So what we saw here was that the robot is able to autonomously navigate from the lobby to the room and created a path that it can follow without any obstacles. It did that autonomously. It oriented itself in the room. And from here on, you can do other things like you can run a machine learning algorithm and detect objects, or you can take vital scans, or you can give commands or talk to the patient. So this is just a very small example to show you the power of simulation and how you can set up scenarios and testing virtually using RoboMaker and the hospital environment. There are multiple benefits to running simulations in RoboMaker. First, the service is fully managed. What this means is that you don't have to worry about managing the Gazebo instances or the software stack. You only worry about developing your domain-specific ROS application. Second is the access to cloud scale. The service automatically scales up the compute that's needed to run your simulations up to 15 virtual CPUs. You can also scale simulations horizontally by running multiple of them in parallel using RoboMaker's Batch API. Third, RoboMaker provides the ability to bring your own simulation worlds or generate simulation worlds automatically using RoboMaker's WorldForge capability, which randomizes furniture layouts and floor layouts, furniture variations and floor layouts, generating hundreds of worlds with a click of a button. Lastly, with pay-as-you-go pricing, you only pay by the minute of the compute that you use. RoboMaker uses simulation units, which is one simulation unit is 1 vCPU and 2 gigabits of memory. And it costs 67 cents per minute. With the power of cloud-based simulations, we have enabled customers to build better robots, safer robots, and include their feature velocity and improve the quality of their code. Here's a partial list of some robotics customers such as iRobot and JPL who are using RoboMaker at scale. The RoboMaker team has also put together a number of helpful links and open source assets as part of our GitHub repo. The link is below. This includes cloud extensions already mentioned, but that can be included in your application. We also provide 3D worlds for Gazebo that can be used out of the box, such as this hospital world, or a warehouse world, a bookstore world, or a small home environment. I encourage you to try AWS RoboMaker and build applications and test your robots faster and quickly in simulations. Visit our website for resources, workshops, blogs, and case studies. Also, check out the training and certification content available at aws.com/trainings. Thank you, and feel free to reach out to me if you have any questions. Also, please fill out the session survey. I had a lot of fun talking to you. Thank you.